All right. Last week on Friday, we looked at a way to estimate square roots. Today, we're going to talk about how to simplify square roots. I know that some people did this in Algebra 1, but not everyone may have done it in Algebra 1. So we're going to do it like you've never seen it before. We'll start with the very most basic ideas, and that is, what is the square root of a number? Thank you. So, the square root of a number is any number that when multiplied by itself gives you the original number. So for example, one of the square roots of 16 is negative 4, because negative 4 times negative 4 gives you 16. So let's go through these pretty quickly. What are the square roots of 36? And both positive 6 and negative 6. Those are both square roots of 36 because either one of them multiplied times itself will give you 36. All right, what about the square roots of 81? Peter, stop talking. Thank you. 9 and negative 9. Now, Chris, sometimes those numbers are not perfect squares, like 17. What are the square roots of 17? Well, the positive square root of 17 and the negative square root of 17. That's the best we can do. That's the only accurate answer. One of the things that we're going to do is use this definition to help us simplify things. So when you have like the square root of 5 times the square root of 5, the square root of a number is a number that when you multiply it times itself gives you the original number. Well, this is the square root of 5 times itself is 5. You don't have to do any work on that. The square root of 5 times the square root of 5 is 5. You okay? Yeah. What's the square root of 17 times the square root of 17 then? 17. So in this unit, we're only going to be interested in the positive square root of a number. This is called the principal square root. It's not really important that you remember that it's the principal square root. Just know that we're only going to be interested in the positive square roots. And the way that we write the symbol is this symbol. This symbol is not just the square root sign. It is called the radical sign. You can also have other roots other than square roots. You can have the cube roots and the fourth roots and the 17th roots. There's all kinds of different roots. So, by definition, the square root of x squared is the absolute value of x. It's always going to be positive, even if x wasn't positive. So when we want the principal square root, a lot of times we just say the square root. What is the square root instead of saying a square root? So for example, the square root of 100 is what? Oh, don't everybody answer at once. What's the square root of 100? It's 10.
10.
Thank you. And the square root of 144 is what?
12.
12. And the square root of 23 is?
Nothing.
The square root of 23. There's nothing you can do with that.
Oh, yeah.
All right, page 2. If the principal square root of a number is a whole number, then the original number is called a perfect square number. We talked about these some on Friday. We used perfect squares to help us simplify, or actually not simplify, but to estimate the value of a square root of a number. Usually instead of saying a perfect square number, we just say a perfect square. For example, 16 is a perfect square because the square root of 16 is 4. It's a whole number. It's not an irrational number. So the reason these are called perfect squares is that if an actual square had that area, then the sides of the square would have lengths that are whole numbers. So if I have a square, you don't need to draw this, just watch for just a moment. If I have a square and its area is 100, how long is each side going to be? Yeah, that's what happens when you listen to someone else. No, the sides will not be 25. Say it. 10, yes. The sides would all be 10. Because 10 times 10 gives you 100, and that's how you find area. So since this is a whole number, 100 is a perfect square. Because if you made a square whose area is 100, the sides would have whole lengths, or whole number lengths. So if the area of the square is 22 square inches, then each of its sides is about 4.7, but not exactly, even then. So here are the first 16 perfect squares. You need to know those. Okay? And it'd be probably helpful if you knew more than those. So I'm going to write a couple of other ones. 17 squared, did anyone know that one? Sometimes I find students know those. 17 squared is 289. 18 squared is 324. 19 squared is 361. And then we'll do an easy one. What's 20 squared? 400. So knowing those forwards and backwards, so knowing if I get the square root of 196, then it's got to be 14. You need to know them in both directions. Okay, so now on to the main part of the lesson. It's simplifying square roots. So we take the square root of a number that is not a perfect square. We can often simplify that square root to a whole number times a smaller squared root. There are two methods for doing this. There's perfect square factorization, which if you can do it, is always faster. And then there's prime factorization. I'm going to show you both for several problems. So let's start with perfect square. What's a perfect square that'll divide evenly into 700? A perfect square that'll divide evenly into 700. This is not rocket science, friends. Well, let's look up here at the perfect squares. Seven's not a perfect square. But how many times does 7 go into 700? 100. 100 is a perfect square. So I could say, okay, this is the square root of 100 times the square root of 7. And the square root of 100 is 10. So that's 10 square roots of 7. Now, in order to do it that way, you have to know the perfect squares well enough to go, oh yeah, 100 goes into that 7 times. If you don't, there's another way to do it, and that's called prime factorization. I don't know if you guys did this last year or not in Algebra 1, so I'm going to show you the way that I do that. So prime numbers are numbers that are only divisible by two things, themselves and 1, and no other numbers. So that's numbers like 2, 3, 5, 7, not 9, but 11, 13, 17. Those are all prime numbers. So what we're going to do is divide this up into its prime factors. And here's how I write it. Some people do it differently. I'm going to start with 700. 7 divides into that evenly, and 7 is a prime number, right? And you get 100. Now I need to think, well, I always try 7 again. 7 doesn't divide evenly into 100. But what is a prime number that does divide evenly into 100? 5. 5 goes into 100 20 times. And it's nice if you use bigger numbers like that rather than the smaller numbers. It gets the numbers small faster. We can do 5 again, and we should do 5 again. We're going to keep doing 5 until we can't do it anymore. So that'll be 4. 2 divides into 4 twice. And then I can divide 2 into 2 and get 1. We'll continue to divide by prime numbers until we get down to 1. Then, what we're going to do, and I'm going to show you a short way to write this, but basically what we're saying is the square root of 700 is the same thing as the square root of 7 times the square root of 5 times the square root of 5 times the square root of 2 times the square root of 2. And what is the square root of 5 times the square root of 5? We did this, 5. And what's the square root of 2 times the square root of 2? 2. And we still have a square root of 7 left. It's 10 square roots of 7. Which is the same thing we got when we did the perfect square factorization. Now, to speed that up a little bit so you don't have to write all this out, what most people do is this. The square root of 5 times the square root of 5 is 5. The square root of 2 times the square root of 2 is 2. And I still have a square root of 7 left. So that you don't have to write all of this out. All right. So your homework tonight is going to be a bunch of problems similar to this one. For each of the following, simplify completely, and then give 2 consecutive integers that the radical lies between. I'll show you what I mean by that in just a second. So first things first, let's simplify this. I find more students do prime factorization than do perfect square factorization. I'll show you both on this one, but you have to know the perfect squares. What's a perfect square that'll divide evenly into 45? 5's not a perfect square. Because the square root of 5 is not a whole number, is it? But, same thing that happened last time. How many times does 5 go into 45? 9 times. Is 9 a perfect square? Yes. So you could say it's the square root of 9 times the square root of 5. The square root of 9 is 3. So that's 3 square roots of 5. If you can think of that, that is always, always faster. For most students, they don't even think about that. They just start by dividing. And we can divide by 5 first. 5 goes into 45 9 times. I can't divide by 5 again, so I'll divide by 3. 3 goes into 9 3 times. I'll divide by 3 again, and I get 1. We keep dividing until we get 1. And then I've got the square root of 3 times the square root of 3 is what? 3. And I've still got a square root of 5 left. That's the first part. The second part is to tell two consecutive integers that the radical lies between. So what we want to do is say the square root of 45 is between this number and this number, two whole numbers. It really helps if you know the perfect squares. So notice that 45 is in between these two, right? In between 36 and 49. So, although you don't have to write this out, this is what we're doing. The square root of 36 is less than the square root of 45, which in turn is less than the square root of 49. The square root of 36 we know is 6. And the square root of 49 is 7. So it's between 6 and 7. So on your homework tonight, it'll have something like this. It has a blank. I take it back. We would just say that it's between 6 and 7. It doesn't have the blanks on it. It's between 6 and 7. That's about how big that is. That's closer to 7 than it is to 6 because 45 is closer to 49 than it is to 36. All right, let's simplify. Square root of 180. What is a prime number that'll divide evenly into 180? Remember, prime numbers are like 2, 3, 5, 7. Yeah, okay, we could divide it by 5. 5 goes into 18 3 times, with 3 left over. 5 goes into 36 times. What's a prime number that'll divide evenly into 36? Pardon? 6 is not prime because it's divisible by 2 and 3. 2. Or 3. Let's do 3. I think division by 3 is easier on this one. 3 into 36 is 12. We can do 3 again, and that gives us 4. 2 goes into 4 twice, and 2 goes into 2 one time. So I've got the square root of 2 times the square root of 2 is 2. The square root of 3 times the square root of 3 is 3. And I still have a square root of 5 left. This is 6 square roots of 5. About how big is it? Let's go back to our table of perfect squares. We're taking the square root of 180. That's somewhere in between 169 and the square root of 196, right? So what two numbers is it going to be in between? Someone said it really quietly. It's between 13 and 14. Because 13 is the square root of 169, which is less than 180, and 14 is the square root of 196, which is bigger than 180. All right, let's try this one. Square root of 216. By the way, just real quickly, how do you know if a number is divisible by 2? if it's even. Even numbers are all evenly divisible by 2. Do you guys know the trick for knowing if it's divisible by 3? Yes. I'm sorry, what now?
Like all the numbers like close together and divide by 3. That means like
That's exactly right. Very nice. If you add, so let me say it for you. All right, shh. If you add 2 plus 1 plus 6, what do you get? 9. Is 9 divisible by 3? Then so is this number.
that's what it's talking about.
It's a trick for divisibility by 3. So let's divide by 3. 3 goes into 21 7 times. 3 goes into 6 twice. Let's divide by 3 again. 3 goes into 7 twice with 1 left over. 3 goes into 12 4 times. I'm going to divide by 3 again. 3 goes into 24 8 times. Can't divide by 3 anymore, but I can divide by 2. And then 2 goes into 4 twice. And 2 goes into 2 1 time. Gentlemen,
Sorry.
so I've got a square root of 2 times the square root of 2 is 2. I've got a square root of 3 times the square root of 3 is 3. And this time, I have both a square root of 3 left and a square root of 2 left. Two times 3 is 6. The square root of 3 times the square root of 2 is the square root of 6. So that is 6 square roots of 6. We'll look back at our table, and after a while you'll start to memorize these. See, 216 is in between 196 and 225, right? So this is somewhere between 14 and 15. All right, a couple more examples. Square root of 147. Is it evenly divisible by 2? No. Is it evenly divisible by 3? Peter, what are you doing? Yeah, 1 plus 4 is 5, plus 7 is 12. Peter, sit down. Is 12 divisible by 3? Yeah, so I can divide this by 3. 3 goes into 14 4 times, which is 12, so I have 2 left over. 3 goes into 27 9 times. What prime number can I divide evenly into 49? 7, which goes in 7 times. So I've got a square root of 7 times the square root of 7 is 7. And I have a square root of 3 still left. $147, that's just a little bit more than the square root of 144, which is 12. And the square root of 169, which is 13. So this is between 12 and 13. So it says, simplify and give 2 consecutive integers so the radical lies in between. So it wants both things. All right, square root of 128. Two. And I'm going to show you a shortcut for this one. And you get 64. If you recognize 64, it's a perfect square. What times what gives you 64? 8 times 8. If this number is a perfect square, you can stop doing prime factors and do this. That's 8 and 8. So that's 8 square roots of 2. If you don't do that, it still works. It just takes longer. We're going to divide by 2, and that's 32. Divide by 2, that's 16. Divide by 2, that's 8. Divide by 2, that's 4. Divide by 2, that's 2. Divide by 2, that's 1. So that's 2 times 2 times 2. And we still have a square root of 2 left. Be careful. The number of people that I've had who at some point in their lives have done this and said it was 6. But it's not 2 plus 2 plus 2. It's 2 times 2, which is 4, times 2 is 8. It works out the same way, it just takes a little longer. All right, so this is a skill that we'll be using in this unit. So I'm going to have you practice that today, and then we're going to get into tomorrow the things we're going to be using that for.